Hello everyone, good evening. This is week three, second lecture, Thursday class. Uh, I'm recording this lecture, you know why? Because this is the working day coming between the holidays. So that's why I'm recording this lecture. So a lot of students request me to record the lecture and then share with the students. So that's why I'm just sharing with you a recording. So let's start our today lecture. This is lecture is related to BI and data warehouses. We are learning today about the basic understanding of data warehouses and also how the data warehouse architecture actually works. And also we will learn about how the different kind of processes of data manage warehouses we can deal with that. And also we learning about the operation side. This is how the ETL process works. So today we have certain contents like BI and data warehouses, data warehouse process and transformation and the load process, data warehouse development, and also implementation issues. So at the last, we learn about the security issues and feature trends. Business intelligence and the data warehouses. Like in the start of the lecture, the first week, we learn already about the descriptive statistics, like how we can describe our data in different contexts. So we learn about the main core ideas, how the business intelligence can help you in different decision making by using the descriptive statistics. So in this context, we learn a lot of different tools, how to manage the data, how to transform the data, how to deal with the data with the missing observation, outliers, and different others issues we can face during the data management processes. So data warehouse is also dealing the different kind of data at the same time, like structured data, unstructured data, text format data, audio data, video data. So that's why data descriptive statistics is not only dealing the quantitative data, this is dealing the qualitative data as well, and the different kind of unstructured data is coming. So, you know, if you are talking about the data warehouses, the data warehouse is also dealing the big data. Big data, of course, you know that the different variety of the data, volume, and the high potency of the data, uncertainty of different variables. Like you cannot say that all the data is coming in the same behavior and the same consistency. So of course we have a high variation and the high speed and how different variety of different contexts. So you can say how the data manage warehouse is actually managing the whole concept of data uh, collection and the storing of the data. So now we are learning about what is a data warehouses. So we already discussed about this is the main objective of the data management is to provide the physical depository and where we can store the data, and also organize to provide the enterprise wide clean data in the standardized format. So you know that when the data we are receiving, so first process is data collection. So the first data collection, and the second is actually data management, and the third is actually data cleaning, and the next format is data standardization of the data. So these are processes coming. We are trying to automate our systems, right? So this is actually we are providing the intelligence system, how your system is more intelligent than the manual system or the old version of systems, how the your data warehouse is more efficient. You know what? If your data management system is efficient, then of course you can get a very good result. So if your data warehouse system is not well developed, so then you can face a lot of challenges in the decision making. So the challenges you can face in different contexts, different ways. Like I can tell you about that. For example, you are not integrating the data rightly. Like for example, data is coming from the one department to three, but we escaping finance department. Yes, you cannot take a right decision if the finance department is not aligned well with your data integration. And the second phase, for example, you are not giving the command just like managing the outlier. Like so, if the software is applying some suitable analysis, yes, you cannot take a right decision because you are not managing outlier issues. Like for example, because if you want to apply the average value of sales, you have you have a challenge with the sales. There are a lot of outliers. So straightforward, you cannot apply the average value as a mean. So same like I can give you a lot of other examples. The data is coming with the high speed. If your system is not capable to manage the data at the same time, so of course you can lose. We can face a lot of challenges, like we can face a lot of missing observations during data collection if your system is not faster than the data processing. Uh, so now we are learning step by step how the data warehouse actually works. In the start, a history of the data warehouses like start from 1970s to nowadays is a very well developed data warehouse structure. So in the start, the people actually were using the manual system, then they convert into the Teradata. So data at that time was very successful to integrate the data, and we can take a small decisions from that particular system. So after some time in 80s, like you can say, well, the personal computers were invented, and then we say PC, distributed DBA, rational. You can say like we were thinking beyond something like how we can personalize the things. So in 1917 or 18s, it was very like a successful era. Like the peoples actually were using their personal computers, but of course at that time, personal computer was not the laptop. It was actually very big machines. In 90s, yes, you can say centralized data storage was integrated, like the different department can integrate different kind of data set. But still, there are a lot of SMEs actually still not integrating the data with the one department with another data, or like other departments. So, of course, this is the big challenge for the SMEs to adopt the system, how they can use different advanced system just like ERP, CRM, like different others, like how they can integrate and they can learn to adopt the automations in their small, I mean, medium prices and enterprise companies. So now we are learning about how the like in 20s, like how the exponentially growing web data sets, like you know why the data mining was introduced in after 20s. So data mining is a very like useful tool. How the system actually automating taking decision either which kind of data actually the utilization of the data and the processing of the data is very much important to understand by the machine, and then can predict and forecast on the basis of the past experiences and the past results. So the very new terminology was introduced: SaaS, SaaS, PaaS, and cloud computing. So in 2010, like you can say, like big data analytics were introduced, like social media analytics, web analytics, and all Hadoop may reduce no SQL. Like at that time, you can say like the data warehouses were very successful at that time. So I am just telling you nowadays is much better than in 2010, but of course we cannot deny the efforts, the initial efforts did by Hadoop. So at that time it was so popular. Even you can use nowadays as well. But of course, I will compare which is more having the impact in the past and current eras. So now we are somehow we are comparing IAS, PAS, and SAS. These were famous terminologies, how it works. So if you are talking about the application data, runtime, and OS visualization server. So of course, this is the comparison how it looks like. So if you see, yes, most of the like system actually having the visualization, but sometime we are facing some challenges. First, I can say for the networking, storage issues is not a problem for any kind of system. So this is just a diagram showing you like all the systems were capable, and now again you can use the system for nowadays data management, data warehouse issues. So I'm just clearing some of the concept how the systems were having this providing the services to the market. So now, if you are talking about the data warehouses characteristics, yes, you can say object oriented, integrated, time variant, and the novel tile, and you can say web based analytics. Now, if you are talking about the web based, so maybe you have experience to see the website in different website are actually counting the number as well, how many visitor visiting this website, and also they are introducing some client services, customer base support. In nowadays, actually, very famous terminologies, chatbots and different kind of bots actually supporting the humanities. Like if you're visiting any website, so the boards are actually providing 24 by 7 services. And of course, by using the past information, by using the existing data, so they are providing you the quick solution, just like Shopee, Lazada, and other chatbot actually providing 24 by 7 services without human involvement. So metadata also does matter, because metadata is actually the combination of all kind of data is storing in the one place. So now we are learning data marts. Data marts is very, very like easy terminology. So you can say the subset of your main data. So for example, data mart is just like, you can say you are running a company and you want to split the data as per the department level. So each department data belongs to a data mart. Like for example, supply chain department is the one data mart. Even if you're talking about manufacturing department, again one data mart. The HR department, again one data mart. Finance again. So now you can easily understand about the data marts. Usually we say DM, but don't confuse about the DM. We usually use the DM in two different contexts. The one is data mine, and second is data mining, right? So now, of course, we can store all the information within the data mart. Sometime we are receiving the data in unstructured format, and we are taking the information from the that we are having this programming, just like in the data warehouses. The data warehouse is actually splitting our data into the different marts, and then we have a flow chart, and we will learn in very detail about the flow chart. So now we already learning about the dependent and independent data marts. So dependent actually subset that is created directly from the data warehouses. So the dependent is the direct subset, and now independent is actually small data warehouse designed from the strategic business unit or the department. So you can say, if I explain in indirectly. So if you are collecting the data straightforward as a data marts, you can say it's a dependent. If your system is actually designing strategically and splitting your data as per the classification of that particular scenario, so then we can say independent data. So we are learning about the data mart components, like we have operational data stores, enterprise data warehouses, and also we have a metadata. So if you talking about the ODS, this is actually the type of data set often used in term area for the data warehouses. In the other side, like if you're talking about enterprise data warehouses, we have a large scale data house where they do across the enterprises for decision support. Like you are not talking about the one way, we are talking about the all different enterprises we have coming on the same platform, and then all the enterprise data is we are storing at the same place. And metadata, of course, this is actually the structured way of data, like how the people's actually collect, how the companies are actually storing the data coming from the different sources in the structure, unstructured, and different other ways. So now we are discussing about data warehouse process. This is most important part of this lecture. Data warehouse is actually okay. We are understanding about the outcomes first. So outcome means like how you can get the benefit from the reduce infrastructure expense, produce warranty expenses, improve cost of quality, ac- accurate environmental performance reporting, and also architecture standardization. So these are the actually you can say findings and output, how you can reduce the cost. So if you are using the data warehouses, yes, you can reduce your cost by increasing the automation, by increasing the AI functionalities, by increasing the different for example, most of the times you are collecting the data, and if you are collecting the data, of course you are working only 8 hours or some 9 hour 10 hours maximum in a day. So if you the machine is actually collecting the data, the machine can collect and uh, take a decision quickly, and can collect the data, can take the decision either the data is in the sequence or is consistent or validated, even the data is reliable or not. Sometimes the data have no any reliability because the data is coming in the same number. Like for example, the data is collected at 10 10 10 10 5 5 5 5 5 5. So we have no any fluctuation within the data, so then we can face some challenges for the future, like then when you are forecasting your data, so we will not find a right output from that particular data set. So now we even we can improve our system. Even for example, in the last lecture we learned about the Six Sigma. Six Sigma actually providing industries are actually using to increase the quality of their products, and also they are following the ISO standards. So you know why I'm just introducing this term, because data warehouse also actually maintaining the quality of that particular system. So how the companies are actually adopting the ISO standards, and then the same concept goes on, like you can consider in the manufacturing items. So now the data is coming, for example, data is coming from machines, and those data is coming directly from the manufacturing machine. So then you can straightforward say, yes, your Six Sigma is directly having impact on data warehouses. So then you can utilize the Six Sigma tools within the data warehouse process. Yes, so that's why I just explain in detail. You can also integrate data warehouses, Six Sigma tools within data warehouses process. If you are collecting the data straightforward coming from the machines or manufacturing process. Now, this is a framework, a complete framework, like how the data sources we are collecting the data from different sources. We have we are adopting the ETL process, extract, transform, and load. This is actually we are selecting the data, then extracting the data, transforming the data, integrating the data, then we are loading the data. So we have a metadata, enterprise data warehouses. We have a replication data marts. Actually, we introduce with the already I explained about the data mart. Mart means is a subset of that particular data. So we are dividing our data into certain classifications. So these classification actually coming from the common identifiers. So we have a marketing, operation, finance, and all other department actually having the you can say these are the marts of that particular data, metadata. So these marts are actually we are taking a decision on the basis of, for example, marketing data is taking the decision on for the marketing. So all the data is going to the end users, or where we can display the data dashboards, where you the peoples are actually can take the decisions. Just like I can say the Sunway University having different kind of they are using data warehouses, and our system eLearn and iZone and all other integrated in one place. If we are using a system, and I want to send an assignment for one student, of course one class, and the students can straightforward receive the assignment in the one click. So it means that the end user can easily facilitate it, like by using this system. And also there are a lot of other examples. All the most of the actually developed and big names actually using the data warehouses framework for the smooth processing and time with the less efforts and less cost, and you can achieve better results. So we are talking about data warehouse architecture. So this architecture is like this is a very simple one. Just you can say we have a three tiers. One is client, another is actually application server, and the last is a database server. So this is actually the three tiers architecture. There are different types of architecture. We are learning a very basic level. So how the system works. So we are integrated with the system. Of course, system is coming always in the middle, and the client workstation is just like a user-friendly atmosphere, and the database service is a we have a metadata. So in the of course, I can give you one example. Like once in my past institute, someone hacked the system, and then quickly, like they recovered because they have a metadata, and then most of the company actually having the data warehouses. And if someone want to hack, so immediately they can easily refresh and take the original data, and then they can easily recover those files. So I'm just telling you, like these architectures are very, very important. If the companies are using these systems, then they can easily do better and also perform very good. So I'm giving you another example. This is actually the two-tier architecture. So where client and the application databases merge together. So this is again, of course, we are combining the application and data uh, database server. So this is somehow very good, but again, we are learning about the data warehouse structure. So some issues for the consideration with the decide the architecture you use. Like we can say, like we can face these four challenges. Um, the first is actually management system, and the second is parallel processing, and the third is actually migration tools be used load in the data warehouses, and the last is actually support data retrieval and the analysis. So everywhere we have some challenges as well. So we cannot say straightforward we can get the results, but we can get the benefit from the data warehouse structure. But structure should be very flexible to use, and but we have a lot of other kind of structures. These two structures were introduced to just give you some exposure how it looks like. Now, web-based data warehouse architecture. So you can say like we have an application when we have a data warehouses. We are all depending on the web server. So we have different kind of web pages, and then the client web browser is just a dashboard where the client can see and watch with different kind of material you are providing. So. There are a lot of example are there, but now I'm just focusing on the application side. So how you can get the benefit from a web service. Of course, web server, there are a lot of thousands of types of web servers available. So just like a shopping, so there are different web server. There are bank website is a web separate, university sites have a separate server. So of course, this is actually called data warehouse architecture. Architecture selection. So 10 factors that we can say to take the selection decision includes like you can say information interdependence between organization unit, upper management information need, urgency of need for the data warehouses, nature of end user tasks, constraints on resources, a strategic view of the data warehouses prior to implementation, compatibility with the existing system, receivability of the in-house IT staff, technical issues, social political factors. So there are a lot of other as well. So now architecture selection have other parameters. We are learning about the data integration and extraction, transformation, and load. So this is you can say integration comprising three major processes: data assess, data federation, and change caption. So, enterprise application integration and enterprise information integrations are two similar terminologies. How you can integrate the data from metadata. What is the main difference? We are comparing both of them. So if you're talking about the enterprise application integration, so we are talking about application. Like application means we are always see like where we can use the sources and for the data warehouses. In other sense, in the second definition, you can say technology and processes that facilitate the automated exchange of information between enterprise application. So, in the other hand, this is the information. So, information always coming from different sources, such like you can say like multi-dimensional databases, web service server, and also you can say from different kind of web services means like just we have done in the first and second class how to extract the data from Kaggle, how to extract the data from Word development indicator and all other sources. So this is actually the information. So information coming from different sources and we are just utilizing different tools to take the decision. So software ability data sees the data and the information of the entire organization as a unified view. So it can be managed as a single source. So yes, if you are managing multiple sources, yes, you can. Otherwise, single source also fine. So in the other side, you can say both are important, both are fine for data integration, but the first is actually focusing on application side, and the last, the enterprise information integration is focusing more data oriented, coming from the different sources, right? So now we can say like how it looks like. So the ETL is actually we have extraction, transformation, and load. In between, we have two steps as well. So we already learn in the data warehouses how it looks like extract, transform, or load. Yes, ETL is very famous terminology. How it looks like. So this is The extraction is actually we are collecting the data from different sources, right? So transformation is again sometime we are receiving data from in the different shape. One data is coming in the row wise, one data is coming in the column wise. So we need to transform the data from rows to column, and then we can compare. Sometimes we are receiving the data from different brands and we need to align the information in the same brand. So this is actually the challenge we are dealing within the transformation. And the load is actually we are putting the data into the channel where the data is required. So, for example, the data is coming from a different source, and the we data is actually in the uh, credit, debit, and something like that. So we think like this is belongs to finance department. Yes, we can put the data into the finance department. So of course we are aligning and integrating the data in the right department or right way. In the other sense, we can straightforward store in the metadata, and then we can make data marts. You know, a data mart also have two different types like dependent data marts and independent data marts. So if the data is coming straightforward to the department storing in the metadata and the data is clean structured, so we can say this is a dependent data mart. So if the data is not integrated, not structured, and so then we can say we have to store in that metadata. Metadata will decide either the data is structured or not. So if the data is not structured, then it will be converted into the data marts, and then we can utilize. So this is a complete structure of ETL. I already explained with example. So this is data is coming, then we're transforming, and then we are cleaning, then we are loading to the data mart. So this is actually the complete structure of ETL. So I'm expecting every group to make the utilize this in your group assignment. So hopefully you will do it. Then I have a small given some limitations like issues with the purchase of ETL tools. So data transformation tools are expensive, yes, because data management is a main challenge. Sometimes, if the data is very, very big, so data transformation tool may have a long learning curve, and also we have important criteria like ETL. So why we are selecting? So of course we minimize the time and standardize the process and utilize the functionalities, tools, and techniques in the right way. So sometimes we are using the old traditional method of statistics, and if you are not able to run the uh, best suitable model, then of course we cannot get the right results. So ETL is that's why very important in all the context. So we have data approaches like these two approaches are so famous around the world. Now, you know why one is actually top-down approach and one is other is actually bottom-up approach. Um, in a model is actually Kimball is actually bottom-up approach. So both approaches are fine. Like sometimes we are thinking and then we are processing and then we are achieving, right? Some businessmen actually just thinking, oh, this is the right time to invest in any company. So then they already predicted that if we are investing right now, then we will get the profit, right? So this is a top down approach. So top down approach, they already have decided like we will get this profit. Like for example, if you are investing in the banks, if you are taking the interest, and these interest says like you will get the straightforward amount and this is actually top-down approach. If you are you have not planned, you are just started your business, and the Kimball model you are using, so this is a bottom-up approach. So now, of course, you can understand easily. So, which approach you are using in your assignment and other business scenarios. So these are two approaches. So some of the slides I'm just giving to you guys. You need to explore, and then you need to um, focus how this looks like. Some of the slides I have not taken from the book. I have researched myself and then added in this lecture. So same like you can say like scope and development time and the cost and difficulty, sources size. So if you see like some of the like DM approach is sometime very good, and sometime we can say EDW approach is more better. But if you are considering EDW approach is more considerable, because in this context we can utilize more better position. Just like you can say historical data, we can utilize gigabytes, like very much data, and also high speed, and transformation is very high in this. So even we can deal with weekly and monthly data. So you can say like uh, of course, if you are dealing the small and medium enterprises, then of course DM approach also fine. So of course this is depend on your company and where you are implementing this system. Now, DM approach versus EDW approach. So about the technology and usability. So of course, if you're using EDW is more better than the DM approach. Now, if you are talking about the additional DW consideration, so you can see like free up capacity of in the house system, and the free up cash flow, and make powerful solution affordable, and all others. So this is again, you can consider these points if you are uh, adopting the data warehouse. So representation of the data in that marts. So of course, already we discussed about the data marts are actually having we can separate according to the need. Like for example, who customer and where market and what product we need to identify within the data marts. Either what you want. So if you are not prepared, if you are not giving the right direction, so you cannot cover these things within that specific time frame. So now, star schema. Star schema again, very important. Commonly used method to simplest things, like how to utilize for dimensional modeling, and also you can say like contain a fact table surrounding and connect to several dimension table. So Snowflake's schema also used the logical arrangement of the table in the multi-dimensional databases, where the entity relationship diagram resemble a snowflake shape. So you can say like how the things are actually dimensions are normalizing into the multiplicity table. So these approaches, we are comparing these approaches here. So if you talk about the star schema, this is actually the one unit is depending having the four different dependencies. If you are talking about the snowflake schema, so we have subsets of that particular item or dimension. So just like you can say dimension product have a further subset. So this is called snowflake schema. So the star schema have the straightforward one-step process. So this is the multi-step process. So this is online transaction approaches, OLTP. OLTP again a famous terminology, and the online analytic processing, OLAP, is again a famous terminology. So if you're talking about the OLTP, this is actually capture and store data from ERP, CRM, POS. act, and also you can say like automate the business process that's managing by the design support by OLAP. So if you're talking about OLAP, OLAP is like designed to address the analysis of the organization data and complex queries. This is usually captured by the OLTP. So this is a complete process. If you are talking about the OLTP, yes, this is data transaction processes, like how the data we are taking from the other systems, and then we are utilizing. So if you, this is a very good comparison. You need to explore more things about the OLTP and OLAP. So these are very, very important if you are processing your data from any source. So you must be in your mind, like keep in your mind like how what is your purpose, data source, and the reporting store requirement and execution speed. So if your speed systems meet and the data speed is not integrated, yes, you cannot face you can face some challenges. Like these tools are actually developed to extract the data from other sources. Okay, and now OLAP operations, like we have slice, dice, drill down, and the roll up and the pivot. So these five different ways to use the OLAP operations. So even you can split subset of the data. So data always have different dimensions. So if this dice you are using when you are two dimensions, if the slice you are using when you have a multi-dimensional. Roll up we use when capturing all the data relation for one or more dimension. So pivot we have a data in a different table, different queries, reporting format. So data warehouse implementation issues, like we are talking about the implementation, and you can say like how it's important to avoid the following issues. Like we're talking about the issues first, and the starting with the strong sponsorship chain, like setting expectation that you cannot meet, engaging in the politically naive behavior, loading the data warehouses with information you can just say like because of its availability is more important. So of course data warehouses design the same transaction but transactional database design. So of course if have the different design of data warehouses, then you cannot integrate the data. So you need to be aligned both the system in the same way, then you can do it. So now, the last stage we are learning about data warehouse administration things, how the data warehouse administration should have a knowledge of high performance softwares and hardware and networking technologies, possess a solid business knowledge and insight, be familiar with the decisions marketing. Of course, data structure is very, very important. So I need to highlight the data structure. You know why? Because if your data warehouses is not familiar with that particular structure, then you cannot integrate the data. Sorry. Data structure, for example, you are integrating and collecting the data in audio format. But your system is developed to collect the numerical data. So you cannot collect the audio data, video data. So you need to be trained your data warehouse administrator. So if that is trained, then you can easily cope up all the issues. So security and privacy in the passing issues in the data warehouses, safeguarding the most valuable assets, government regulations, and the most be. So of course, you need to follow all the ISO standards and all company standards to meet the expectation about the security. So nowadays, of course, data security is the high paid jobs. If you are becoming a I know that when I scrolling, so I found lot of data securities you can say cybersecurity. These kind of actually jobs are more uh, like giving you potential and all giving you more salaries in this context. So this is very, very important if you are focusing for the job perspective. So future of data warehouses, sourcing infrastructure, and how the web, social media, and big data analytics are actually behaving. Cloud computing is also very important nowadays. Most of the people actually going to give the lecture and they are carrying nothing, like they have no anything. So all the things are actually having on the available on cloud. So we just having the internet and then quickly we can open and then deliver our lectures. So this is just a context of the students. Student also using advanced systems nowadays. Even they have their own metadata, and they most of the data scientists have their own metadata, and also they're hosting and different people are actually having their own websites they are operating and um, running their own website for different kind of purposes. So there is a data management practices technologies. This is very, very important, and also in databases in memories processing new systems, how they are managing the different data marts. So thank you very much for today lecture. So if you have any question, we can discuss in detail. So hope to see you in the next week. Thank you. Take care.